Hi everyone, good morning, good afternoon, good evening, depending on where you are, and welcome to this webinar. So this webinar is part of a trilogy of three sessions. The first one was in the beginning of July on the topic of the persistence of microbiological hazard in the food industry, and we had the chance to welcome Brice Maviel from Kersia and David Thomas from bioMérieux. If you miss the first one, we will be able, if you send us a message, to send you the link of the replay. Today, it's the second webinar of the trilogy, Monitoring Hazards, Importance of a Good Environmental Monitoring Program to Seek and Destroy. And we have the pleasure to welcome to this for this session two speakers, Lina Otero, Global Expert Service Manager at bioMérieux, and John Holah, Director of Scientific Committee, Pioneering Food Safety Association, and is also Honoray Professor of Food Safety, Cardiff, Metropolitan University. So you are all on mute mode. To ask a question, please click on the question icon in the toolbar. The webinar is recorded, so we will send you the link after the event for your convenience. You will receive after the session a satisfaction survey. So please, if you can take 2 minutes to answer the question, it will be appreciated. So now it's time to introduce our speaker. So Lina Otero. So Lina began her professional career over 15 years ago, developing and delivering publicly funded programs that enhance food quality and safety standards across Colombia. After gaining years of insight in the challenges facing the industry, she moved to one of the world's leading biotechnology companies to help. Lina now spends her time traveling globally to collaborate with the world's leading companies in the food industry, integrating digitalization tools, new technologies, and processes to improve problem-solving and decision-making. Lina has a microbiologist BSc from the Universidad de Los Andes in Colombia and a postgraduate specialization in epidemiology from the Universidad del Rosario. And as you understood, Lina is coming from Colombia. John Holah, following retirement from Kersia in December 2022, John established Pendennis Food Hygiene Ltd and provides consultancy on food safety incident management, environmental pathogen management system, hygienic design, and general food hygiene. John remains active with Kersia as the director of the Pioneering Safe Food Scientific Committee. From January 2021, John became a principal corporate scientist for the Kersia Group, having been technical director at Allchem Laboratories Ltd since 2014. Prior to this, John was head of food hygiene at Camden BRI for over 20 years. John is also an honorary professor in food safety and hygienic design at Cardiff Metropolitan University. John's work has covered the design of the food manufacturing infrastructure, building, equipment, and processes like personal hygiene, cleaning and disinfection, maintenance, resulting in guidance on many of the hygiene practices used today. Internationally recognized in the troubleshooting and management of the Salmonella and Listeria, John continues to add to the scientific literature and is the editor of a trilogy of food hygiene books. He has supported the EIFP, EHADG, SOFHT, and GFSI for many years, has chaired various ISO, CN, GFSI, and AHADG committees on hygienic design and chemical disinfection. And he has sat and sits on UK government committees on food safety and hospital-acquired infection. So, wow, an impressive, I would say, background. And John, the floor is yours for the first part of this webinar.
Thank you. Can I have permission to share, please?
Yeah, I think now you have.
Okay, hopefully you can see my presentation.
Yes, we see it, John. You can go.
Excellent, thank you. Good afternoon, everybody, or good evening. I'm going to talk a little bit today about the history of environmental sampling, why we do it, and perhaps how we can do it a little bit better. So, as a starting, I'm going to be European focused. Environmental sampling differs in different parts of the world. This is going to be sort of European focused. So why do we do environmental sampling in Europe? And it's legislation driven. The Hygiene Directive Regulation 852/2004 requires us to consider the compliance with the microbiological criteria for foodstuffs. So the microbiological criteria for foodstuffs is laid down in another directive 2073/2005, which gives criteria about food safety relative to a range of microorganisms, their toxins and metabolites. So we have legislation in Europe about the microbiological criteria of food. It goes a little bit further. This should include testing against the values for the criteria of food through the taking of samples, the conduct of analysis, and the implementation of corrective actions. So we have criteria, we need to sample product, particularly conduct analysis to identify the microorganisms, quantify them, and then implement any corrective actions. Sampling of the production and processing environment is recommended, but it's also mandated for certain microorganisms such as Listeria and Enterobacter sakazaki. And then finally, there is suggestions that food business operators should decide themselves the frequency of that testing. Beyond legislation, much of Europe works to GFSI-led best practice through compliance with food safety audits from the likes of BRCG or IFS, etc. And this is some clauses taken out of the current BRC version 9 document. And there is a requirement there within this standard for risk-based environmental programs shall be in place for relevant pathogens or spoilage microorganisms. And there is some specific requirements there on the design of the environmental monitoring program, the control of actions, and its review. So essentially, in Europe, why do we need to do microbiological environmental sampling? Because microbiological criteria for food products exist. Food testing is mandatory. Environmental sampling is recommended or mandatory, dependent on the pathogen. It gives a requirement to sample to ISO standards. It requires corrective actions if limits are exceeded. And environmental sampling plans are recognized as best good manufacturing practice. So there is quite a lot of for us as food manufacturers to undertake environmental sampling plans. Given that we have to undertake these sampling plans, what are the fundamentals that we're trying to achieve? Firstly, as Guillaume mentioned, hunt and destroy. We're trying to find pathogens. If it's not worth our while undertaking environmental sampling if our objective is not to try and find a pathogen at the end of the day. However, we recognize that there are other testings going on of product, packaging, in production tests, etc., and it must be complementary to those. It must also complement any pathogen prevention strategies that we have. Factories now have listed strategies, salmonella prevention strategies. Our environmental sampling plan must be complementary to those. We have to incorporate the verification of OPRPs and PRPs that are specifically control pathogen hazard. It must be complementary to other rapid hygiene monitoring methods, such as ATP testing or protein testing, which are also trying to give evidence of cleanliness or general hygiene standards of our equipment or environment. It's got to be value for money. Every sample must have a reason. And ultimately, every sample must have an investigational plan if a positive is found. The last thing we want is to be worrying about what do I do next. If I find a positive, we should have that in place before we start. One practice that I've learned over the past is that sampling materials should never see a laboratory until the point of analysis. They should always be delivered to the factory first. Then sampling takes place, then ultimately are taken to a laboratory. There should be no possible chance of laboratory contamination or sampling materials. Policies, procedures, training in place for all the methods that we describe. And then finally, unique, I guess, for Europe, we don't undertake indicators. They have no value for pathogens, but they may suggest if environmental conditions are out of control. So if we look at enteros in the dry food industry, an increase in enteros might suggest a leakage of water into the factory, etc. But they are not an indicator of organisms like salmonella. So just as a sort of a review, where do microorganisms come from within a factory? And on the left-hand side, they can arise in the raw materials, in the water supply, in any processing aids that we use, and in the packaging materials. Externally from the factory, we might see things like listeria in the environment, in the air, the soil, dust from our effluent plants, or carried by pests. Equally, to manufacture foods, we need food operatives, we need tools, we need things like cleaning chemicals, etc. All of those can bring contamination into the factory. And we see it at three levels: external, what is around the factory site that could get in and contaminate; what is within the factory site, such as toilets, the canteen, maintenance activities, laboratories. They may be a source of pathogens. And then finally, in our internal, within the food processing area, environmental harborage of microorganisms. So in green, the raw materials, water supply, packaging may be picked up by product sampling. The rest in orange are more likely to be picked up ultimately by the environmental sampling plan. We think of sources of contamination and vectors take that source of contamination to the product. And we only have three mechanisms in which a product can be contaminated. It could be from the air, either sedimentation if it's still air in a room, or entrainment into the food if we're using air or gases to move the product or do something with the texture of the product. From surfaces, be they hard surfaces like a conveyor belt or soft surfaces like an operative's hands, and from liquids, from processing fluids, deliberately like washing the product or fluming or soaking it, or accidental contact with cleaning fluids or aerosols. They have a transfer coefficient, so what percentage of the microorganisms in the environment will get into the food. And there are variables, mainly due to the number of microorganisms out there and the chance of contamination. But the three key things are airborne, surface, liquids. There are only three routes of product contamination. We have sources where listeria or hiding or indeed growing if it's a growth niche. And microorganisms go from those sources directly to the product by product vectors, again, air, contact to liquids, or may move to a secondary source. So they could be moved on people's footwear, on the wheels of bins or trolleys, etc., to a secondary source. And then from that secondary source, by, again, the vectors to the product. So we need to identify potential. We need to identify particular routes of transfer, the vectors, within our factory scenarios to really understand the potential for cross-contamination. We also have pathogen control philosophies that we use within Europe. This is a 5-point plan for pathogens, where the philosophy is you isolate an area in the factory, often a high hygiene zone or high risk zone, and you then consider preventing entry of a pathogen into it, looking at the infrastructure to restrict the possibility for harmage and growth of that pathogen, looking at the GMPs during production to try and reduce cross-contamination vectors, and then employing a good cleaning and disinfection program to remove any pathogens that have passed through those barriers that particular day. And there's a link in this back to the first webinar, which looked at EFSA's control of persistent factors and hygienic design, which in this model is the restrict harborage and growth, the infrastructure, and the barriers, which again in this model are the preventing entry, are the two top factors that EFSA recognized in terms of the control of persistent pathogens. So sources, vectors, models, that's in place now. Where are we sort of historically? Well, environmental sampling has been practiced for many, many years in Europe. It's the way that we always look at food manufacturing. We take samples of the product, we take samples of the environment, but we were never really sure why we were doing environmental sampling, or if we were, it was the last technical manager or the technical manager before that, and we inherit a sampling plan that we're not really sure why it's in place. Often we follow retailer requirements, which might be 50% of samples from food contact surfaces, 50 from non-food contact surfaces, but there's no real structure to it. We never had anything in place if a sample was positive. There was a requirement to think on your feet very quickly to try and understand what was happening. It was seen as an expense rather than a value. There was no obvious reason for it in many cases. And if we did think about it, we were trying to reduce costs. So in this example here, we have 3 process lines consisting of a slicer, a conveyor, and packing. I could sample each line, each slicer, conveyor, packing every day. That will be 9 samples. But I can try and reduce that samples by taking 3 a day, and by using a structure like this. So on the first day, I take one line, slicer, conveyor, and packing. And then over a period of a week or so, I sample everything. So I get a picture of what's going on by taking 3 samples a day rather than 9. So we had plans in place, but they were for cost reduction or reducing samples rather than looking specifically about what we were trying to achieve. Then we've had 2 models about how to sample the environment. And the first published model was a proximity model in North America. And it has the concept that pathogens move from zone 4 through zone 3, zone 2 to zone 1. Zone 1 is a food contact surface. Zone 2 is close to zone 1. Zone 3 is a processing area. Zone 4 might be external to it. So if you find a pathogen in zone 3 or zone 2, essentially you're finding it on that journey towards zone 1 and you're preventing contamination of the food. It works in the basis that you take few samples in zone 4, many more samples in zone 3, most samples in zone 2, and very, very few in zone 1 because they're seen as in the US as seen as product samples. The proximity model works quite well if the vector is surface-based. So if you have a lot of activity in zone 3 and zone 2, and here a transfer, the surface might be people, then the model works well. The closer the organism is to zone 1, which is for then the more chance it is of getting into zone 1. But if we take other vectors, the air or liquids, it has no value. So if there is an airflow from zone 4 through the processing environment, it has not a proximity, it has a direct vector. Testing it at the top of the picture here is useful if you found it in the air, because it will go onto zone 1. Testing it after, as it's going out of this door, has no value, because you don't know whether it did go over the food or it's come later. The liquid only appears really within zone 1, so you don't taste it from outside. So sometimes a proximity model works, but for other the air and the liquid aspects of our vectors, value. The other model is a process environmental plan, and this has come about really because HACCP was seen as brilliant for the process, but maybe not as good for the processing environment. And we see it develop through FSMA in the States, where there is a requirement not only to think of the process, but also the processing environment as a source of pathogens. So we have this triangle in the middle, and at the bottom of the triangle is everything that you would expect to have in place, usually determined as either best practice or GFSI compliant audits. They will all require building design, equipment design, maintenance, sanitation, etc., that you should control those, and that will be part of your prerequisite plan. Those prerequisites will have to be managed, validation, monitoring, and verification, and those will sit to your environmental sampling plan. We have this grey area then of management of specific hazards within your unique processing environment. And part of that now is controlled by our in this case, 5-stage pathogen control plan, and it becomes part of the process environmental plan. If we look more closely at the process environmental plan, it has 14 aspects of it, which have been derived from the 14 aspects of HACCP. So obtain management commitment, define terms of reference, select, but instead of selecting the HACCP team, select the process environmental team, describe the environment rather than describing the product makeup, construct a flow diagram, etc. And then we get into the codex parts of it, identify particular hazard sources and vectors, and control, and the rest is HACCP. So we have a process environmental plan that's mirroring HACCP and is trying to identify risks within our process and environment. The other key aspect of difference from HACCP is constructing a flow diagram, because we're not constructing a flow diagram of the process, which might have all of the ingredients and the processes and the line that the product takes, as we would see in a HACCP plan, but we are describing the process environment. And we start off with a plan of the operation, in this case, a meat slicing operation where logs of meat come in from the right-hand side, and they're nitrogen frozen and then sliced and packed. And then on top of that, we can look at we can look at people movements of specific racks or other utensils in there. And we build up a 3D picture of what is happening to try and understand where pathogens might move to or where they come from if we subsequently identify them. So key to this is trying to assess a factory for its sources and its vectors. And these are just some classic examples of where we might look. So on the left-hand side, we have water leaking from under a structure. That is the classic for listeria in chilled food plants, and it's very difficult to control. We can perhaps disinfect the surface, but that's about it. We have cracked drains and floors. The next one is a seal under a door, which has got a biofilm growing on it because we can't access it to clean. We might see it behind checker plate walls. We might see it in frameworks, in fluids from condensers. There is a roller here that is poor hygienic design, and if you break the roller apart, you will find fluids inside which contain microorganisms. Or often the worst case on the bottom right hand side is our services, particularly our electrics, and here you can see a broken protective covering over our electrical wires, and when I lifted it up, you can see water running out. Vectors are contact with surfaces, the air, etc. So starting on the left hand side, we have a conveyor belt that is too long and touches the floor. We have cleaning of conveyor belts on the floor, so you have direct transfer from the floor to the conveyor belts. We have a compressed air line on touching the floor, which then will connect to its outlet and blow contamination in. We have allergen spoon contained in a cleaning system that should be color coded. We have things like drain covers being put directly onto the conveyor. We have a hose pipe over the conveyor. We have product contact pipes that have gone into a drain. And worst of all is probably telephones and calculators, etc., as a vector. So our model is trying to look at our factory for all of these particular sources and vectors, and then installing controls. So the first level of control is just remove the hazard. So here on the left-hand side, we've got packaging material on a line, and somebody's cleaning the drain. Now, clearly, the easiest thing to do is just take the packaging material off the machine before cleaning starts. This was below it. This was an area where there was listeria leaking out from underneath this chiller unit, and I've got now storing packaging material on it, and the packaging material is touching the floor where the listeria is. I could isolate this area and stop people walking down it, people putting trolleys of packaging, etc., to try and isolate that area. In the middle, I've got cleaning being undertaken with open product. It's spraying aerosols on, so I need to put some screening in place. On the right-hand side, dismantle this piece of equipment and I'm cleaning it on the floor. Well, really, I should have some form of trolley or support mechanism, and I can dismantle my equipment onto the trolley and clean it there. So my idea is sources and vectors, and then making sure controls are in place. I can go a little bit further. I can risk assess my sources and vectors to see which are the most important. Risk assessment of sources is all about the potential for it to be contaminated and the potential for it to spread. Risk for vectors, again, the potential for the hazard source to be contaminated, but the frequency of the transfer vector. So I can try and control sources, or I can try and control frequencies to think about controlling sources and vectors. I can go a little bit further, and I can follow a HACCP philosophy of trying to assess the risk of the source or vector without controls, and then assessing the risk after controls have been put in place to ensure that my controls are useful. So on the top line is these little buttons on a meat slicer. They had water in them, and these have been seen as classics in the past of transferring listeria. This button has been tested many times. We've never found listeria there, but we do then clean it and disinfect it periodically during the day. I can look at risk in terms of medium, low, medium, high, or I can transfer that into a figure of 1, 2, 3, and I can create a risk score. This one is Listeria behind this plate on the wall, and this is a corridor where lots of people, lots of traffic goes through, and there's Listeria onto the floor. So the risks are different. I know Listeria is here. It's a possibility there. I have a risk score of 9 for this, but I can't really control it. I can disinfect around here, but I can't get behind the panel where the Listeria is. This is a slicing machine, which meat slicing has been recognized for many years as a risk in sliced meats. There are many incidents of pathogen associated problems. And one of the ways, particularly in North America, they're trying to cope with this is putting the whole of the slicing machine in a plastic bag and steaming it to try and disinfect it cleaned. So we've got a high risk of Listeria being there, as witnessed by several big incidents. However, when I put my control in place, I get a low risk score because the control is working. I can take that to the next level and decide what I'm going to do. So for my switches, I just see it as a normal prerequisite program, and I will need to add that to my environmental sampling program. So I need to perhaps swab around the switches periodically to ensure that there's no Listeria if this was in this case, the particular hazard was present after a cleaning and disinfection program. The wall, I can't do anything about. I have to argue with senior management for CapEx to try and to improve that situation and retrofit. However, the control of the slicing machine is an operational prerequisite because the risk is so high without the control, but the control works. So I then build into a system where I have new prerequisites. I can add to the prerequisite management plan for my generic prerequisites. I can add to my environmental sampling plans of my verification of monitoring, etc., from those PRPs and OPRPs. There is a relationship between my sampling strategies. So what I'm trying to source during the sampling program is are the processing area barriers preventing pathogen entry? So I sample around my barriers. Is everything under control during production? So I sample my known sources and vectors to make sure that my controls are working. But I have to look at collectors, footwear, wheels, cleaning equipment, etc., to see whether there is general evidence of presence of a pathogen in my processing environment. Personal freedom samples, where if I think something is wrong, I can do some sampling. And I also need to verify that my cleaning and disinfection program is working. And ultimately, my environmental sampling becomes a journey. And the size of this, the sample number, I'm trying to reduce the number of samples over time, but increasing my confidence. I start off as a random situation where I don't really understand what my environmental sampling program is trying to do. I then perhaps integrate a model where I then start sampling barriers. I try and investigate my sources and vectors. I reduce my post-hygiene samples. I then put in controls for my sources and vectors. I perhaps then introduce collectors to try and look at the general perception of pathogens in the environment. And ultimately, I end up with some barrier samples, source and vector control samples, collectors, freedom and post-hygiene. And I'm now in a predictive situation where if I find an organism in the environment, I can do something about it in good time. So frequency, in Europe, product sampling and environmental sampling is about the same in terms of numbers. We should sample operational prerequisite controls more than prerequisite controls. We should sample prerequisite controls more than prerequisite controls with supporting evidence. So in terms of cleaning, we don't want to do too many tests after cleaning because we already have hygiene tick sheets to say that it's been cleaned, or ATP results, etc. We've got plenty of evidence that our control, the cleaning is working. Perhaps we look at as a proportion of 50 or 60% of our samples to control prerequisites, maybe 10 to 20 as generic collectors, barriers 10%, and fewer post hygiene, etc. Negative results, we need to ensure that we are taking samples correctly, we are using correct laboratory procedures, etc. That our sampling programs have been verified and validated by a laboratory, and occasionally we can sneak in some low-risk samples that might be positive. Root cause investigations really relate back to the sample. If a barrier sample fails, what has gone wrong with control? If a post-hygiene has gone wrong with my cleaning and disinfection program? If it's a source and vector, what has gone wrong with my routine controls? And if it's a general collector, where does the organism come from? Where can it go to? And I can then come back to the traceability concept of using my digital plans that I have to superimpose the potential movements of pathogens over there. And I can then try and make an assessment of where my organisms come from, where it's going to, how to control it. So that's me, and this leads into particular sampling methods that we use by investigating, which will come with whole genome sequencing, which will be part of the next webinar. So thank you very much.
Thank you, John. Thanks a lot for this very nice presentation, very insightful. We have some questions, but I will keep them for the end of the webinar. And now I will let the floor to Lina. So welcome, Lina. I let you share your screen for the second part.
Thank you, Guillaume. And thank you, John, for sharing all the knowledge and experience that you have around environmental monitoring with us. So we are going now to go more into, yeah?
Yeah, perfect.
Good. So now we are going to go more into the details of the offer that we have at bioMérieux around environmental monitoring. So we have identified 4 main challenges or main pillars that different food manufacturers have when they are implementing and executing the environmental monitoring programs. So the first one that we have identified is on the design. How do I design the more appropriate program for the facilities that I have? Then in terms of execution, which kind of tools I use to execute my environmental monitoring program. The third challenge that we have identified is in terms of the analysis of the data that is produced by that program. How do I visualize the information? How do I go deeper in my root cause analysis? Do I have the full visibility of what's happening in my facility? And of course, the improvement is how do I use all that information and all the data that I'm collecting from the testing in my facility to improve the plan and to move to a more proactive and more preventive approach than just reacting to results. So for the first challenge in the design, we have developed an e-learning, an interactive e-learning that has 6 modules that will support you on first to say what is environmental monitoring and why it's important to have an environmental monitoring program in your facilities. Then the second one is more about how do I deploy this or what I need to take in account when I am developing my strategy for environmental monitoring. And finally, it's how do I implement this environmental monitoring in my facility. So that's for supporting our customers on the design of the environmental monitoring program. In terms of execution, we have developed instruments and technology automation that you know for detection of pathogens, of quality indicators, and also in partnership with our sister company, EFSA NutriScience, we have a dedicated software to manage environmental monitoring that is a cloud-based software that can help you from scheduling, automated scheduling of your sampling, tracking all the information, mapping, having visibility, and standardizing between different sites, also with real-time notifications. For the analysis challenge, we have both. It's more dedicated for the root cause analysis. So let's say that in case of having out of a specification or non-conformities, we have developed technologies that you can use in-house in your facilities to track deeper and identify which is the source of the contamination and to be able to implement better responses based on that information. And we have also developed some genomic services where we have identified that genomics or whole genome sequencing are services that have been for a while in the market. But the main challenge that we see is that it's not easy to read this information. So we have combined the expertise from microbiology that we have and our bioinformatics and data science team to be able to walk with you through these results and facilitate the interpretation of these genomics results. And it's the services that we are offering in terms of analyze for root cause analysis. And finally, for improvement, because the whole point of making all these tests and analyzing the data is to use all that information to improve the program that we have. So we have developed a specific softwares, and we have a specific dedicated data science team to be able to analyze all the data that you have collected through a period of time to be able to use that information to improve the program that you have in your facility. So to focus first in the benefits that each of these main pillars that we have defined can bring to you. In the first one, for the design, the learning, what it provides is a better understanding of the why. So if you understand why you are doing the environmental monitoring program and what do you expect to do, it will drive a better implementation and execution of that program. And what are the main benefits that you can expect by doing this e-learning? First, to understand if the current program that you have, if it's efficiency or not, and which improvement opportunities you have so you can apply it. The second benefit is to have your sampling plan under control, how to have your sampling plan under control. Also to establish positive detection protocols. This means, what do I do when I have a positive? So if you have heard one of our experts, Jack van der Sanden, webinars in his bear hunting, he always said, like, sometimes we develop these programs to find the pathogen, but when we found it, we have not developed what to do how to react when we have a positive. So that's part of the learning, is to support you on what to do when you found a positive, and also what to do if you are not finding those positives. Then another benefit is that it allows you to standardize across different sites. So if you have a multi-site company, you are able to have the same guidelines and the same protocols, and you can standardize this program, the execution of this program. And last but not least, the benefit of having more value for money. So we know that there's a big investment around the environmental monitoring program. So what we are looking through this e-learning is to really capitalize on the actions that you do and to get improvements and better outcomes in your facilities. So for the execution, we main focus in automation and digitalization. So as I mentioned at the beginning, we have both instruments, technologies, and softwares to support the execution of your environmental monitoring. The instruments are to support you mainly in the early warning, so in speed and getting like faster results to be able to make faster decisions. but also robust technology that can give you trusted results. Because there's no point on having the information quick if you cannot trust in that information and you cannot make a decision in should I release or not this product, should I release this production line or not. And in terms of the software, the main benefits of our software is first to eliminate all that non-add value tasks. So through the studies that we have made in several of our customers across the world, we have identified that around 40% of the time of a technician in a laboratory is invested on admin work. So just managing data, writing in Excel files, and so on. So the idea of this software is to eliminate all these tasks that add no value to the people, the team that you have, and to be really reallocate that time in actions that really add value. And the second benefit is, of course, the traceability. So you can have all your information collected in one place for your own analysis or to be able to respond to internal or external audits. And combining these instruments and softwares, you can get standardization. So you reduce the variability that you have on the execution of your environmental monitoring program by combining automate instruments and digitalization of the data. And of course, you will save time. And last but not least is the analysis. So this is how we support the root cause analysis on genomics and Typer. I will not go into the detail of the offer that we have because, as John mentioned it before, we have the 3rd of October another webinar that will be specifically dedicated to root cause analysis. I would just highlight that the solutions that we have are dedicated in-house to make faster decision making, but are also to support you and to improve the pathogen root cause analysis that you might have when you have a contamination, how to be able to decide and to identify if this is a new challenge, it's a challenge that you have had before. And the third benefit that we aim to bring you through our genomics offer is to improve your spoiler identification and investigation. Either if it's an identified spoiler that you already have, so help you to track you, or if you haven't been able to identify that spoiler, we can help you through our genomics offer too. Thank you very much. Guillaume, the floor is yours.
Thank you, Lina, and thanks a lot to all the attendees for the participation. We are a little bit late, but maybe we can take a few questions we had on the chat. The first one, maybe it's more for you, John. What potential guidelines should be included in the validation of the applied environmental pathogen monitoring?
Absolutely. If the prerequisite plans that you're going to put in place for sources and vectors are managing a hazard, they have to be validated. And there is some guidance from the European Hygienic Engineering Design Group on validation of cleaning and disinfection programs. There is less guidance available on managing generic PRPs other than sort of best practice. But once you've found a source, once you've found a vector of where these pathogens are coming from, you have to put a control in place, and you need to validate that that control is working. So one classic might be for Listeria, it is fluids coming out onto the floor. You can't control the fluids coming out on the floor without renovating the factory, but you might be able to disinfect the area that is wet. So I can start off disinfecting every 4 hours, and then I would sample 3 hours, 59 minutes later. And if I find Listeria, then 4 hours frequency is too much. And I need to go down to 3 hours or 2 hours. If I don't have listeria there, I've validated that my 4 hours practice of cleaning around that wet area is sufficient. So if I understand the question correctly, there is some guidance on validation for cleaning and disinfection, but not so much guidance on normal prerequisite or operational prerequisite controls.
Thank you, John. Another question, maybe for both of you. We speak a lot about digitalization. We see that data is coming to be the new oil. Why do you think environmental monitoring programs are still managed manually or with Excel? I
Want
don't
to
know
start,
if-
John?
So I believe that we can improve environmental sampling in 2 ways. We can improve it by being more focused on why we're sampling, where we're sampling, taking fewer samples, but giving us more confidence that we've found an organism if it is there. And then the second aspect of it is trying to use modern technology to help us then understand the results of those samples. If we find it, where has it come from? What is it, etc. So I think we have 2 opportunities: an opportunity to improve generically our sampling plans, but also an opportunity to improve the output of them through using digitalization. And it's tools that Lina was outlining that will, I think, become incredibly important in the future as we go forward.
Yeah, I think that in my experience visiting customers and asking them how they manage environmental monitoring, I think that the main difference that I see is when a food manufacturer actually understands why they are having that program and what are the benefits expected from that. Those are the kind of customers that have already moved forward to a digitalization and have evolved from Excel files to softwares. The challenge for the other customers that are still working on Excel file is because they are still struggling on how to prove the value and the benefits that having an efficient environmental monitoring can bring, so they can support the idea of investing in a software. So I think that that's like the 2 profiles that I have seen. And that's why, as I was mentioning, we have developed support for both profile of customers. So if you are in the first stage where you already understand the value and you're ready to move forward to a software, we can support you with the software and digitalization. But if you are still struggling with the program, how to develop and how to prove the value that it brings and the benefits, we can also support customers on that challenge.
Thank you, Lina, and thank you, John. I see the time is running, so it's now the moment to close the webinar. To thank both of you. Thanks a lot, John, and thanks a lot, Lina, for your insight. Very interesting. Thanks to all of you in front of your computer. And it's not finished because the 3rd webinar of the trilogy will be held on the 3rd of October, and I will have the pleasure to participate to this webinar to deep dive in the root cause analysis tools, a new era thanks to genomics, and we will co-animate the webinar with Magali Ledi-Odic, which is market manager, food safety and dry cleaning at Kersia. So now I wish you a good day, beautiful week, and in 1 month, we will meet again. Bye-bye.
Thank you, everyone. Bye.
Thank you.
Bye.